think we can start. Then maybe this one we take up to 1:30. Is 1:30 okay? So, having looked at the data quality issues, uh, the next question was now on where does data come from? So, basically, in most cases, as we define traditional data and new data, um, we have seen that there is a distinction between the two in form of data and so on. So mostly traditional data comes from basic customer records, like the records that you have in an organization, historical stock prices, information, and so on. So traditional data mostly comes from there. Then when we are talking, for instance, the basic customer records, it can contain information like the customer identity, records, maybe how many times they have filed a complaint, the amount of money spent maybe in a single purchase, and maybe if the customers are maybe members of a scheme, their address, contact information, and so on. So, historical stock prices, for instance, on other hand, can contain dates of observations like stock. Maybe we are talking about like shares, Safaricom shares, how has it been performing, and so on. They must contain dates of observations, the name of stocks you can have, Safaricom, income, and so on, and the prices. So basically, like if you look at this infographic here, this is something like stock prices and so on that you can see. So basically, in summary, is that when we are talking about traditional data, the source is the records that are found within the organization. Now, looking at big data, what called the modern kind of data, you can see I have used like an image as I was explaining. Mostly, we see that this big data has come as a result of technological advancement. So, as people are posting a lot of information on social media and so on, it leads to the transmission of what called big data. So, we are seeing that a consistent growing number of companies and industries generate big data. So, for instance, if you have online communities such as Facebook, LinkedIn, financial trading, and so on, that's all big data. And also, we can have machine data from sensors in industrial equipment, also amounts to big data. And wearable, let me explain this part. For instance, I was explaining you see that you are working on oil and gas industry. So you see, oil and gas mostly is being transported using pipelines. So you can put sensors that can detect if there is any case of leakages. So the data collected by the sensors and transmitted to the database is part of big data. Another one is wearable. Wearable tech is like you have something like a wristband that maybe is able to collect data on your body, maybe pressure and temperature and so on, and transmit it. Those are what called wearables. It's like something that can be worn as a wristband and so on. So we are seeing that currently the volume of digital data amounts to 90% of the data. And all this digital data, 90% of it, it has been generated in the past 2 years. That's why this now emerges. You see, a lot of data has been generated within a very short period of time. Now organizations are struggling to get very skilled people to be able to manipulate and make business decisions or for decision making. And a lot of data, of course, is going to be generated uh, going forward. So now, having looked at the sources of this data, the traditional and non-traditional, the next question is now, who handles the data? Who handles the data? So, uh, the data specialists who deal with raw data and processing with creating databases and maintaining them can go or can be given different names. So the people who handle data can be those people who create the data. So when we are talking about people who handle data, it means it can be various. It doesn't mean a specific person. So we have the differences in the roles of these people. For instance, we have someone called a data architect, then we have what called a data engineer, or sometimes they are called big data architects or big data engineers, depending on the volume and type of data that is being handled. So, for instance, a data architect creates the database from scratch. Like, what it means is that, like, if we want to construct this house, an architect has first of all to design how the structures will look like, the outlook, and so on. So that's what a data architect does with regards to data. So, so these people, they design the way data will be retrieved, processed, and consumed. Like, how will we get this data from the database, right, to retrieve? Then, processed, like, am I going to get it in form of an Excel file? Then, how am I going to consume this data? So that's the purpose of a data architect. So now going to data engineer, uh, a data engineer now uses the data architect work as a stepping stone, then processes or pre-processes the available data. So in short, data engineers ensure data is clean, organized, and ready for the analyst to take over. So these people ensure that this data is okay for other people to use. If data has a lot of rows and columns that are not supposed to be used, they remove and so on. So data engineers, in summary, do what called data pre-processing. And we say that data pre-processing is a method to ensure that this data is clean and ready to be consumed. Then also we have this person called database administrator. So is the person who controls the flow of data into and from the database, how data is being accessed. Yeah. So a database administrator gives you just an access to it. So, but there's something here, this last statement is saying that with big data, almost the entire of this process is automated. As I mentioned that with SQL and so on, you can just link the database so data comes direct, it's being transmitted, you get dashboards like visualizations in real time. Like, as data is streaming in the database, the dashboards keep on changing, maybe refreshing after 1 second, 2 minutes, without you again downloading, analyzing, then updating. So you see, with the emergence of big data, this role is becoming redundant. Like, you don't have to wait, I don't have to wait for you to come and give me access to data. So that's what that one means. So that role is almost becoming redundant because this work can be automated by those who handle data. So that one leads us to somewhere again after knowing the people who handle data. Of course, later again I'm going to show you, like as a data scientist, which roles can you work? I think that will be the last. But now, let us first of all look at data science explaining the past. So when we are talking about data science explaining the past, we are talking about business intelligence. Like you have data explaining what happened in the past. So we are saying that we have two ways of looking at data with the intention to explaining behavior that has already occurred in the past. So if you have gathered data for it, or you use the data you already have in order to predict the future behavior that is yet to happen. So basically we have two aspects here, two ways of looking at data. One, with the intention to explain what has occurred, and two, with the intention to explain or to predict what might happen. So, but now, before we go to what might happen, which is called predictive analytics, we must first of all look at the patterns of behavior the past provides. We look at the past first, then we analyze them, draw insights, and inform the path for forecasting, like the future. And therefore, this business intelligence focuses on this by providing data-driven answers to questions, some questions like what happened in the past. So, the first one, for instance, you are interested to know maybe how many units were sold, in which region were most units sold, how did the email, for instance, you have various marketing strategies in an organization. Maybe how did the email marketing perform last quarter in terms of click-through rates and revenue generated? Then how does that compare to the performance in the same quarter of last year? So we are saying, in short, that although business intelligence does not have data science, in its title, it is part of data science and not in any trivial sense. So, business intelligence, when you're talking about business intelligence, we don't have the name data science mentioned, but we are saying that it is part of data science. It is a subset of data science. So, in summary, business intelligence, what it tries to tell us that you have past data irrespective of the industry. Then you are using that data to explain what happened in the past. Then after knowing what business intelligence is, now it is important to know what does a business intelligence analyst do, BI, business intelligence. So, as you have said that data science can be used to measure business performance, but in order for the business intelligence analyst to achieve that, they must employ specific data handling techniques. We have the specific. First of all, the starting point of all is data. You must have data. Then after that, there's this statement, it's not about data. You say once the relevant data is in the hands of the BI, relevant data is in the hands of the BI analyst, for instance, monthly revenue, customer sales, etc. They must quantify the observations, calculate key performance indicators, then they examine the measures to extract insights from their data. Because even before you analyze, like, you must know what you want. Like, what do I want to achieve with that data? I want to calculate maybe the mean sales, the average sales over this specific period, or I want to know the maximum and minimum sales volume and so on. So it is very important, first of all, to quantify and come with those KPIs before you go with further analysis. So, in summary, data science is about telling stories. So, apart from handling strictly numerical information, data science and specifically business intelligence is about visualizing the findings and creating easily digestible images, and these images must be supported by what? Supported by most relevant numbers. This is an example of this image. You see, this guy has a dashboard. It has a pie chart and a bar graph. So this is one of business intelligence. So, for instance, before you come up with this dashboard, there is data that you have used. When you are going to the management to present, you cannot go with Excel spreadsheets and whatever. For them, this is what they want to see, so that when they see, they can easily understand and interpret. They are not interested on the technicalities. For them, they are interested in a simple thing that can be used to make business decisions. So, as that one leads us to the second statement, we are saying that all levels of management should be able to understand the insights from the data and inform their decision making. So it is very important if all levels of the management are able to understand and inform decision making. So business intelligence analysts create dashboards and reports, and these dashboards and reports must be accompanied by graphs, diagrams, maps, and other comparable visualizations. And the purpose of all of this is to present the findings relevant to the current business objective. So again, that one leads us to some, it must be relevant to what you want to achieve currently as a business. So that is what a business intelligence analyst does. Like the critical thing you can pick here is that in summary, all this statement, if I want to summarize, is that irrespective of how technical you are, you must be able to come up with something that can be easily understood. Meaning that the communication aspect is critical. Here, it is communication. How are you going to communicate your findings to various stakeholders for decision making? This is what all this is telling us about. So the next question is that where, for instance, is business intelligence used? One is maybe price optimization. So, for instance, this is just an example. In price optimization, you extract relevant information in real time. So after that, you compare with what happened, the historicals, and then you take actions accordingly. So I have a very simple example here, like on hotel management behavior and so on. So for instance, prices of rooms are raised in period when many people want to visit the hotel, and reduce when the goal is to attract visitors in period with low demand. So optimization there comes in a situation. You see, currently we are going towards the festive season, and mostly find in regions like Mombasa, the accommodation and whatever is like the prices is going to go high because many people like going for holidays there. So what is happening now? During that period, you optimize, like you make sure that also you raise your, because there's a lot of demand and the supply is low. So you optimize by raising the prices, of course, to a considerable level to avoid customer exploitation. Now, during the off-peak season like January and so on, the supply is more than the demand. So for you to attract demand, you lower. So you find out, yes, you have charged more here and you have lowered the prices in January, still the business will be in a position to be sustainable. So all that is done through modeling and so on to ensure profitability. So that is what we call optimization. Uh, Another one that is common is inventory management. So this one to ensure to handle over and under supply. So maybe how does it work? So you do an analysis of the past, maybe sales transactions, then you identify seasonality patterns like the movement at what point do we have the peak and so on. Then at the times of the year with the highest sales, which results in implementation of effective inventory management techniques that meet demand at a minimum cost. Like what it means when you are supplying your products and so on, you don't just supply the same quantity across the year. So because it might lead to a waste, maybe let me say in situations whereby, let us use an example of umbrellas. Umbrellas, mostly, many people purchase umbrellas during rainy seasons. But also, even during sunny seasons, we might have some like mothers with young kids having umbrellas because of the scorching sun and so on. So, you know the seasonality, how the graph looks like. Maybe in April, there's high chance that it is April, May, March, so April, from March, April to May. In the past, before climate change and so on, we used to receive a lot of rainfall. So during that time, we optimize by ensuring that the supply meets the demand. Then during the low season, of course, we are able to predict. All that we are going to learn in both the statistics unit and machine learning, how you can do that. Then the next question is, who does business intelligence? So we have someone who is called a business intelligence analyst. This person, the focus is reporting and analyzing historical data. Like you analyze and report on historical data, what happened. You use historical data to do your analysis. It's called a business intelligence analyst. And there's something that confuses people. Have you ever heard of business analyst?
Yes.
So,
The same thing.
no, they are not doing the same thing. Because a business analyst, let us say this organization, maybe we need to implement a new system on student management system. A business analyst will come and look at, for us to purchase that system, what are the system requirements? Do we need, like if he assesses the infrastructure within here, that will it need us as an organization to purchase maybe laptops that are compatible with that system? Two, you will look at the staff. Do we have skilled people to manage that staff? So to manage the system. And so he assesses the whole scope of business, system requirements, and so on. Then recommends. That's a business analyst. He looks at the gen, but a business intelligence analyst, this one deals with data. They look at what happened. They use data to look at what happened in the past.
So the business analyst is mostly like more in tune with IT.
Yes, IT. They work mostly with IT. Exactly. They work with IT department. Yeah.
continue.
Yeah. So after that, we have what called business intelligence developer. So a business intelligence developer is the person who handles more advanced programming tools such as Python and SQL to create analysis specifically here designed for the company, not the general analysis. So it is the third most frequently encountered job position in business intelligence team. Like you want to customize your dashboards to meet the company data, the company brand, and so on, something like that. That's a business intelligence developer. So another one is a consultant. Of course, consultant you are just supporting, giving advisory, and so on. It's just an external business intelligence analyst. So the BI consultants will be business analysts if they were employed. Like if you employ, you see when you work in an organization full time, you become an employee. Part time, maybe consultant. So that's the difference between the two. But now, the dynamic nature of the role provides the consultant with a different perspective. And whereas the business intelligence analyst has highly specialized knowledge, the consultants contribute to the depth of data science team. You see, consultant, of course, before you become a consultant, you need also to have been an expert. But if you look at most consultants, they don't stay in the organization. They just come, see what you have done, advise you do like this, do like this, then they disappear and so on. So that's how they work. So we have all of them, in some and all of them just do the same thing, but maybe at various levels. Yeah. But now, the last thing I want us to look, as we summarize, career pathways is in data science. Like after you finish this course,
Yes.
what are the career pathways? That is what people are interested to hear.
Yeah.
So I want to start by saying it depends on the organization. Because organizations that have a lot of money, they might need to have a lot of team members handling specific tasks. But those that do not have so much budget of hiring, they can employ one person as a data scientist to handle all the, how many roles? 1, 2, 3, 4, 5, 6, about 5 roles. But the first thing you can work when you finish the data analytics course, you can work as a data analyst. This person deals with data manipulation and reporting, a data analyst. Again, you can work as a machine learning engineer. For them, they create what called algorithms for data science processing. Like we saw that example of Tom in the image I showed that slide, what he was investigating to predict if I think the water was causing diseases, something like that. So that's a machine learning engineer. You create algorithms for data science processes. Another thing, you can work as a data engineer. Data engineer, we have said, their role is to do data processing. And data pre-processing, your role will just be to prepare that data for further consumption by other team members. Yes, analysts and any business intelligence analysts and so on. Then, another role, you can work as a data architect. Your work is just to build new database system and like how data is collected, stored, and so on. This is another role you can work. Then you can work as a business intelligence analyst. We have said for them they make decisions based on past information of data. But above all, is this master, the data scientist. So they analyze complex large volumes of data and support business decision making. So in some organizations like my last employer, I was working as a data scientist I was doing as a data analyst, ML engineer, data engineer, and business intelligence. The only role I didn't do is this one. This one was being done by the IT team. So it depends with the company. They can hire you as a data scientist to do how many roles? 1, 2, 3, 4, and 5, of course, 4 there. But others that have good budget, they can hire separately. You can have a team, you work as a data analyst, the other one is working as a data engineer, the other one as a machine learning engineer, and so on. So this one is dynamic based on organization, budget, and structure. But as a data scientist, you can work in all those roles. Like at the end of this certification, you can work confidently in all those roles. So that's where I wanted us to stop for today. Next weekend, we start on data science predicting the future. So what I'm going to do, I have shared the notes in the WhatsApp, but I'm sending by email. Yeah. No, no, I have shared just the entire this unit, the whole of this unit, and also recording. But I'm sharing. I'm going to send by email also today because WhatsApp you can use it. You can use the phone and everything goes. So this is where we will start next weekend. We meet same time 10. Yeah. Yeah, we go from 10 to, we said 2. We have said 1:30. 1. We said 1. Yeah, 1.
Yeah, we can do the session till 1.
Yeah, till 1. Yeah.
There is no need for the break and then 1 hour.
Yeah, sure. So we will do that. I hope the class has been good.
It has been insightful, yes.
Yeah, and informative.
Yes.
Yeah. So thank you so much.
Thank you so much as well.
Yeah,
I will
so
see you next
Saturday, yes.
Yes.
So we meet Saturday same
At 10.
at 10, yeah.
Would there be someone else in this physical class or?